In this video, we are going to learn how to solve a quadratic system of inequalities. So we're going to solve each system by graphing and then indicate 1 point in the solution set once we've done so. So we'll start on the example on the left. Y is less than negative x squared minus 9x minus 2, and y is greater than x squared minus 2. So we'll start with that first equation, which I'm going to put into vertex form so I can more easily find the vertex, make it easier to graph. So I have to take y is less than, and I'm going to factor out that negative, so negative of 9, let me start over there. Y is less than negative of x squared plus 9x, and again, it's going to be plus some other number. And then minus 2 minus that number I find times negative 1, since that's what I factored out. So that number I'm adding there is half of 9 squared, so 9 halves, which is 9 over 2. So 9 squared is 81 over 2 squared, which is 4. So it's 81 fourths. So we'll have y is less than negative of, this factors into half of x plus half of 9, so 9 halves squared. And over here we have negative 2 plus 81 fourths, which we have to rewrite negative 2 as 8 fourths so we can find a common denominator, giving me y is less than negative of x plus 9 halves squared, and then plus 73 fourths. So to help me graph, 73 fourths is about 18.25, or exactly 18.25, and 9 halves is 4.5. So I'm doing x plus 9 halves, so when I go to graph, I'm going to do this one in red. I'm going to go to negative 4.5, which I'm counting by 2s, so negative 4 is just slightly to the left, and all the way up to 18.25, so 18 here is counted by 2s. It's a little bit above that, so this is negative 4, a little bit left, a little bit up, about right there would be where that vertex is. And then I see I have a y-intercept of negative 2, so all the way down here is another point, and I can reflect that point across. So again, I go from 0 to 4.5, and then go 4.5 to the left to 9, which would be between negative 10 and negative 9, which is between negative 10 and negative 8. About right here. That's plenty enough points to start drawing my quadratic. Now, when I start to draw, this is strictly less than, so I'm not going to include the line as a solution. So it's going to be a dotted or a dashed line through the points. And already I can see that it's going to be everything less than it, so very lightly I'm going to start shading everything below the quadratic. So it's everything within that umbrella. If it was greater than, it would be everything on the outside, because that would be above the line. So below the line is everything inside the parabola. Greater than would be everything outside of it, above the line. Now we have y is greater than x squared minus 2, which is already in vertex form. So I'll graph this one in green. And that vertex is at 0, because there's no number on the inside of the squared, and negative 2. So they actually intersect right here at this point, which I'm going to talk about in a little bit. But I need another point. So this vertex is about around negative 4-ish. So I'm just going to plug negative 4 into this inequality, or into that equation, just to see where the other point would be. So negative 4 squared minus 2. So 16 minus 2, which gives me 14. So at negative 4, this other graph goes up to 14. I can also reflect that across its axis of symmetry, which is at its vertex. And again, this is strictly greater than, so I'm going to use a dashed line as I go through. So it looks like it crosses around the vertex point. I can't tell if it's exactly at it, but it's around it. but we have two intersection points. And again, this green is everything above the green line. So it'd be everything inside of it as well. So if I go from one point straight up, you can see that I'm inside the parabola. So the 2 points where they intersect, since we're not including the lines, those intersection points are open circles where they intersect. Mainly because I can't include that as my solution, but the two overlapping shaded regions are right here in between the two graphs. So this shaded region I'm filling in right now is the solution set to the inequality. So now we want to point out a solution in that set. So I'm going to look inside my shaded region, and at -2, it looks like right here at, and then 6, so -2, 6, I should have a solution. And just to be doubly sure that is a point in the solution set, I'm actually going to plug them into both of these inequalities to see if it's true. So if I plug in 6 for y, I get 6 is less than negative of -2 squared minus 9 times -2 minus 2. So 6 is less than negative of 4. Then -9 times -2 is plus 18 minus 2. Well, this is a -6 minus 18 plus 18, which would be 12. So yes, it's true for the first inequality. We could try the next one. 6 is greater than -2 squared minus 2, which will give me 6 is greater than 4 minus 2, which is certainly correct. 6 is greater than 2. So just to be sure, that is a point. And you could have picked any point within that set to solve that problem. Now let's look at the next example on the right. We have y is greater than or equal to x squared minus 5x plus 4, which again, I'm going to complete the square just so I can figure out where the vertex is. So I have y is greater than or equal to x squared minus 5x, which I'm going to separate from the 4. I'm going to add a number on the inside and subtract on the outside. So I'm not adding any additional value to this because I'm going to add it then subtract it. But the number I'm adding is half of -5 squared. So -5 squared is 25. And it would be -5 halves because half of that. And so 2 squared would be 4. So I'm adding 25 fourths to complete the square. So I'll also subtract 25 fourths. So now I get y is greater than or equal to x minus 5 halves squared to complete the square. And then 4 minus 25 fourths, to find the common denominator, I would have to think of that as 16 fourths minus 25 fourths, giving me -9 fourths. So now its vertex would be somewhere around x is 2.5 and 9 fourths about 2.25. So x minus 5 halves, so I go right to 2.5. So I'll have this graph be in red. So 2.5 in between 2 and 3, and then down 2.25, 9 fourths. So -2.25 would be about right here. I see I have a y-intercept of 4. And then if I went 2.5 to the right, so that's 2.5 across, go another 2.5 to the right. Here's another point, and here I can see that it is a solid line since it's equal to. So when I draw this, I'm going to draw it with a solid line. Now, I'm going to put the other equation in vertex form by completing the square as well. So we have y is greater than x squared plus 3x, which I'll put in parentheses to separate it from the -4. And whatever I add in here, I'll subtract on the outside. So half of 3 is 3 halves. So 3 halves squared is 9 fourths. 9 fourths, so I'll subtract 9 fourths as well. So I get y is greater than, completing the square here and factoring, I get x plus half of 3 squared. And on the outside, that 4, again, can be rewritten as 16 fourths. And combining those two numbers gives me 25 fourths. So I get x plus 3 halves squared minus 25 fourths. 25 fourths is about 6.25. 3 halves about 1.5. So when I go to graph this equation, which I'm going to do in green, I'll go left to 1.5, so between -2 and -1, then down to 6.25 with that subtraction. So -6, a little bit below it, about right here. I have a y-intercept of -4, so I can put a point at -4, which reflecting it, that's about 1.5 away, so I'll go 1.5 in the other direction. And then this will now be a dashed line, so I'm going to dash it. And I haven't shaded yet, but I'm about to. So again, for the red line, it's greater than or equal to, so it's everything shaded above the line, so inside of the parabola. And then for the green line, it's also greater than, so everything above the parabola, which again is inside that bend of the parabola. And we'll see here that they start intersecting in this little space right here. The two graphs only intersect once, but since one line is dashed and one's solid, they need to both be solid for the point to count. So again, that spot where they intersect is an open circle, and then everything in the combined shaded region right here would be part of the solution set. And now let's see if we can get a point within the solution set. I can see here if this is 1, I can go straight up, and probably 1, 4 looks like 1. So 1 to 4, so right here. And just to be sure that's in our solution set, we can test it out. So plug in 4 for y, so we have 4 is greater than or equal to 1 squared minus 5 times 1 plus 4. So 4 is greater than or equal to 1 minus 5 plus 4, which would be 0. It looks like, because 1 minus 5 is -4 plus 4. So 4 is definitely greater than that. And then I can also plug into the other equation. So 4 is strictly greater than 1 squared plus 3 times 1 minus 4, which also would give me 0, because I get 1 plus 3 minus 4. So 4 is definitely greater than 0. So now you're wondering, here's equal to, there, or strictly greater than. So along this red line, those are all solutions as well, while along this green dashed line, those are not solutions. So you can consider that when you think about your feasible points that could solve this system of inequalities. And that is how you solve a quadratic system of inequalities.